we talked about quadratics and transformations and able to identify the transformations of a quadratic from the parent function to its current position. Now, one of the new things we're going to talk about is vertex. The vertex is the highest or lowest point on a parabola. Now, parabolas are U-shaped graphs. And when the parabola opens up, the vertex is the lowest point on that graph. As every point to the right and left of the vertex is going to be bigger than it, and it will be the lowest point. The vertex is also helpful in graphing, because if I have the vertex, all I've got to do is find 2 points to the left of it and 2 points to the right, and I can graph the rest of the parabola. Same thing is true if it opens down. The vertex is the highest point, the biggest point, when it opens down. The main way we know if it opens up or down is if the value of A is positive or negative. If the value of A is positive, it's going to open up. If the value of A is negative, it will open down. It's all of our reflection across the x-axis. So the vertex is nice to know, and it is the point H, comma, K, or H and K. If there's not a number in place of H or K, it's understood to be 0. Because y equals x squared, the parent function, you don't have to write this, is our parent function. There is no H, there is no K written in, so it's understood to be the point 0, 0. It's on the origin. So, in that little gap right there, we're going to put this in here. We're going to fill these in, so I put it above that. Above example, what is that, 3? And so, yeah, so right where you have the up, down written. So between that and your next problem, yeah. Yeah. So I added this in this morning because I want to look at vertex. So put it before this problem, but after this. So in that little gap between the two. Because what I want to do with this here is identify the vertex. Given these equations, we want to identify the vertex. So, let's see here. Almost found it. Too far. Put it right there. Right there. Yep. So, vertex is the point H, comma, K. In the general form, is this here. Now, yes, I did not write the point or our value B in front of the X. And for this here and what we'll do in this class, we're not going to see too much of having a horizontal stretch, horizontal shrink, or reflection across the y-axis with these kind of identifying the vertex. And it's not because it's hard, it's not because it's difficult, it acts weirdly with our horizontal translation. It messes with that value of where that is actually at. Now, if we look at G here, do we have a value for H? Yeah, we have a value for H. It is this one right here. Now, would that value of H be positive or negative? Positive, because our X minus H, X minus 1, H is going to be positive 1. Now, what's our value for K? Is there a value written out here? No, so it's understood to be 0. Because there's not a number there, it's understood to be 0. Now, we don't write plus 0 because there's no reason to. It's just extra work for us to do. It doesn't tell us anything. And that's also true when we talk about transformations. We're not going to say that our K value is 0, which tells us it moved the function up 0. It didn't go anywhere. It didn't change anything. So there is no reason to list it as a transformation. But when we talk about the vertex is a point on a graph. So having a k value of 0 actually means something in terms of the vertex. Doesn't have any meaning in terms of a transformation, but the vertex's y value is 0. The x value would be h comma k. We plug in h and k, and we get the vertex. Questions on this first one here before we look at the second one? So when we look at the second one, first thing we need to do is find the values of h and k, yes? So h is inside the parentheses because x minus h. And what's our value of h? Negative 10. Because since it is plus 10, the only way we can line this up with the general form is that really we're looking at not x plus 10, but really x minus negative 10. So the value of h is negative 10. What about our value of k? Negative 3. Do we have enough information to find the vertex? Yes. H comma k. Well, h is negative 10 and k is negative 3. And being able to list these out, h and k, we'll eventually get p and some other terms, but being able to identify these does make parts of this chapter, a little bit nicer. Let's look at the last one, negative 4 times x plus 1 squared minus 5. H would be indeed negative 1, and k negative 5, telling us that the vertex is the point negative 1 and negative 5. Now that helps us because it tells us what the highest or lowest point of this parabola is. And it gives us a spot, especially if we're graphing. I now know where to go for my 2 points to the left and to the right. So like the last one, negative 1, negative 5, my other 2 points that I would need to graph is going to be when x is 0, x is 1. 2 points to the right. My 2 points to the left would be negative 2 and negative 3. Plug those in, get the y values, we can now graph it. Because for a parabola, we need 5 points. Questions on those here? The only other thing we're doing today is applying these transformations. We're going to do 3 of them. And then you'll have the rest of the class time to work on the assignment. So let the graph of G be a vertical stretch by a factor of 2, and then a reflection in the x-axis, followed by translation 3 units down of the graph of f of x equals x squared. Write a rule for G and identify the vertex. So we have 3 transformations going on here. Vertical stretch by a factor of 2, reflection across the x-axis, and then 3 units down of the graph f of x equals x squared. So I would do these one at a time. I'm going to start with the vertical stretch. I'm going to call it h of x. Doesn't really matter what we name it. But our vertical stretch and shrink, the general form of this here is a times f of x, where a is the amount that we stretch or shrink the function by vertically. And for us, the amount that we're stretching or shrinking the function by is 2. So since we know what the value of a is 2, we can plug it in its place.
Can I have your attention? This is the last call for any senior who has not gotten their photo taken. If you please go to the library. Thank you.
Now at this point here, we still just have f of x, yes? So we can replace it with its function, which is x squared. At this point here, we can multiply or distribute the 2 through, telling us that after our vertical stretch of 2, the function at the moment is 2x squared. Our next transformation is a reflection in the x-axis. Now, normally, in the general form, we call it negative f of x. But since we're not applying it to f of x, we're applying it to h of x, we would say negative h of x. We're just multiplying a negative through the function to get there. Yes? Well, that would just be negative times our h of x, so negative times our 2x squared, which is negative 2x squared. Now, the nice thing is with this here, for the most part, that reflection across the x-axis and the vertical stretch of 2 are both being applied in the same way, but for the most part, there's not a whole lot of interaction. So we could have just, in this case, multiplied from the start by negative 2 and gotten here. And the last piece is down 3. F of x plus k, or in this case, we're going to say m of x plus k, because we're applying this to our negative 2x squared. Now, the amount that we're moving is 3, but because we're going down, we're going in a negative direction, our value of k would be negative 3. We're going to subtract 3. M of x, we can replace it here. And yes, if you're wondering, it looks like we just multiplied the x squared by negative 2 and then subtracted 3 and got there. And that is essentially what we did. And the way they have this written, the way they have this set up, we could have just replaced a with negative 2, replaced k with negative 3, and gotten to our answer. And that's purely based off the way that they set this up and set the transformations up in that order. Which is fine, and it works if the reflection and the vertical stretch are first. We don't have any movement up or down. We don't have any value of k either from the start or applied before it. It works just fine. But if we do this in a different order, if we have the translation 3 units down, then the vertical stretch, that factor 2, isn't just going to be in front of the x squared. It's also going to have to be applied to that 3, that down 3. So, again, I don't like doing that just plug it in method because, yes, if it's ordered in this way, it works fine. But if it's ordered in any other way besides this set pattern, it doesn't work. And I'm very much a component of if it's a way that works, it works every time, I'm for that. I do not like ways that only work in this setup in this specific way when it's done this way. That's too of a niche, too small of a hole. I would rather have a thing that works no matter the setup than learn a way that only works in this one case. So, only thing we have left to do is to identify the vertex. H and K. Well, let's look at K first. What is our value of K? K would be -3. It's outside, yes? What's the value of H? 0. Because H is located inside parentheses, yes? We don't have parentheses, so H has to be 0. Now I'm going to write this here below. Do not write this. I mean, you can if you want, but really, if we wanted to see H, we can, because this here, x minus 0 squared. We would never write it this way, because x minus 0 is the same as just x, yes? So I don't need the parentheses, I don't need the square, because it's just x by itself. We just say x squared. But these are the same thing. Because the parentheses aren't there, we understand that the value of h is 0, and it simplifies. Questions on this here? Let G be a vertical shrink by a factor of 1/2, followed by translation 2 units up of the graph, f of x equals x squared. Again, it's another one of those that we could just stick it on there and it would work, but I'd rather step through it. Vertical stretch or shrink, if we're applying, it's a times f of x, where a is the amount that we're stretching or shrinking the function by vertically. And the value of a is 1/2. Do we still have f of x? Yeah, so when we apply it to it, we're just replacing f of x with what it's equal to. And say we have 1/2 times x squared, which lo and behold is 1/2 x squared. Now the only other transformation is a vertical translation 2 units up. So h of x plus k, our value of k in this case is +2 really telling us just this here. Questions on how we got that there? Switch your square in the parenthesis. Square would want to need to be on the outside. Vertex for this here, h is still, well, 0, k is 2. So we get 0, comma 2. We feel good with this here. Let the graph be a horizontal shrink by a factor of 1/3 and a reflection in the y-axis, followed by a translation 2 units up of the graph f of x equals x squared. Write a rule for G. Now the first thing we have is a horizontal shrink by a factor of 1/3. Now in the general form for horizontal stretch and shrink, we have f of a x, where a is the amount that we stretch or shrink it by, but we have to flip that factor of a. Now because they told us it was 1/3, the value we plug in for a is not 1/3, but 3. We have to flip it. Now at this point here, we can replace every x in f of x with 3x. And since f of x is just x squared, it becomes parentheses 3x close parentheses squared. Now our second transformation is the reflection across the y-axis. On the general form, that's f of negative x. But since we're not applying it to f of x, we're applying it to h of x. We would say that our new function, we'll call it m of x, is going to be h of negative x. Which means every x in f of x is going to be replaced with negative x. Now at this point here, we can multiply. 3 times negative x is negative 3x. Now, I didn't say it here, but we're just going to leave it as negative 3x squared. We're going to leave it in that parentheses as it is right there. Now, there's nothing wrong with multiplying it out, but we want to try to keep it in, for at least these problems, as close to vertex form as we can. Last step is our up to. Since we're going up 2, the value of k is positive 2. So we replace k with plus 2. Now that we finished typing in and plugging in our values for k, we can replace m of x with its function and then simplify, giving us this here. H and K. What's our H for this here? 0. I don't have a number added or subtracted from x here, so it's understood to be 0. K is 2. So our vertex is the point 0, 2. Questions on this here? And that is it. So your homework is this here, problems 3 through 11 odd, so only the odds for 3 through 11, the odd number problems. 17 through 21 odd, so the odd number problems from 17 to 21. 27 through 29 all, and 31 and 33. On 3 through 11 odd and 17 through 21 odd, you just have to describe the transformation. You just have to describe the transformation. 27 through 29, describe the transformation and identify the vertex. No graphing. Not going to have you graph on any of them. And then 31 and 33, apply the transformation, identify the vertex. So you don't have to graph on any of these here. They just describe the transformation for 3 through 11 odd, 17 through 21 odd. 27 through 29 odd, you are still describing the transformation, but you do need to identify the vertex. 31 and 33, apply the transformations and identify the vertex.